co-host.
I'll make you the host right away.
Host.
I'll make you the host right away.
Host.
Make you the host. Sonal, it's streaming live, so all yours.
All right. Thank you, Ashish.
Sonal, it's streaming live, so all yours.
Very good afternoon, people. So anybody here who is there from yesterday and have done the homework? Whatever the questions we have taken, 5 questions. Anybody here? Okay. So I'll start the session otherwise then. So yesterday we have spoken about divisibility rule, right? So we have discussed the divisibility rule of all right. So we have discussed divisibility rule of 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So a quick recap. Divisibility rule of 2 is that last digit should be even. So when we talk about 2, last digit should be divisible or last digit should be even. Should be even or should end with 0, 0, 2, 4, 6, or 8. For 4, it was last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. And then comes 8. So in case of 8, it is last 3 digits should be divisible by 8. So that was for 2, 4, and 8. So now when we talk about 3, sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3, right? For 9, it is sum of the digits should be divisible by 9. So we are done with 3, we are done with 9. Divisibility rule of 5, last digit should be 0 or knows this last digit should be 100% 0. So we are done with 5, we are done with 10. Now 6, divisibility rule of 6 should be divisible by both 2 and 3. Should be divisible by both 2 and 3. Okay, we are done with 6. 11. Divisibility rule of 11 is sum of the digits at alternate places. Sum of the digit at alternate places and their subtraction. Their subtraction should be equal to 0 or 11. So this was about 11. Now 7 was exceptional case. We need to double the last digit, that is multiply by 2, double the last digit and subtract it from the remaining digits. Subtract from the remaining digits. So this all are available on internet also, and we have practiced few questions yesterday. So today again it's a number system. Tomorrow we will do more rigorous revision. So one more thing I would like to tell you here, like last time, somewhere at the end of the exam, people have got the notification, those who are preparing for IND SAT exam, they have got the notification that pen and paper will not be allowed. So our approach should be in such a way that if any question comes up, so we will practice all the questions. We will look at all the types of questions because we are not sure now whether they will allow pen and paper or not. Because if they are allowing pen and paper, then we can expect some medium to medium level of questions. But if they are not allowing pen and paper, then we should be able to solve questions orally also. So we will practice both simultaneously. All right. So let's move on. One more thing we have discussed yesterday, that was to find unit digit of a number. So unit digit of number was very simple. Very first step, we'll divide last two digits of power by 4. Last two digits of power by 4. I hope you remember why we divided by 4, because of the cyclicity rule. So cyclicity rule of 4 says, cyclicity rule of 2 says that after every 4 digits, the number repeats, like 2, 4, 6, 8. Not only 2, we have seen for other numbers also, like for 3 also, it is 3, 9, 7, 1. I'll repeat. For 2, it was 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. For 3, it is 3, 9, 7, 1. Again, it will be 3, 9, 7, 1. For 4, it is 4, 6, 4, 6. It keeps on going as 4, 6, 4, 6. For 5, it is always 5, 5, 5. For 6, it is always 6, 6, 6. For 7, it is 7, 9, 3, 1. 8. For 8, it is 8, 4, 2, 6. For 9, it is 9, 1, 9, 1. Though for 4 and 9, it repeats after every 2 number, but still we will go ahead with saying that 4. That's the rule we have made. So last two digits of power, divide by 4. Divide by 4. Second step was focus on remainder. Focus on remainder. Third step, if unit digit of given number is n, then answer is n to the power r. And one more step, if remainder you get 0, then you need to take it as 4. If remainder is 0, make it as 4 or take it as 4. Nobody asked me yesterday why we have to take it as 4. So I'll quickly tell you why we are doing this. So here, this is like 1, 2, 3, 4. These are the powers. If you see, these are the powers and these are the numbers, right? So if you will divide 4 by, if you will count, let's say count first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So every multiple of 4 is coming here. So like 8, 12, 16, 20, 24, and so on. So if you will divide 31 by 4, you will get remainder as 3. If you will divide 29 by 4, you will get remainder as 1. If you will divide 20, if you will divide 30 by 4, you will get remainder as 30. Divide by 4, you will get remainder as 2. So you will get remainder 1, 2, 3. But if you're dividing by 4, you will never get remainder 4. What else you will get? You will get 0 as the remainder. So if you're dividing, you will get 0 as the remainder. And we don't have 0 here. So that's why it is either 0 or 4. All right. So that's the reason. If I take 12, let's say a number is 758 to the power 612. So I have to focus only on this part. So I'll take 8 to the power 12. Now first step, I'll divide the last two digits of power, that is 12, divide by 4. I know that the remainder is 0. So I cannot write 8 to the power 0, right? I cannot write this as, I'll write it as, if 0 is the remainder, I'll write it as 4, because where the 4 is, where the 12 is coming here, it means that in this column, in the last column. All right. So I hope you understood. I repeat, why we take 4 as when the remainder is 0, why we take it as 4? Because when you keep on counting in a repetitive way, after every 4 counts, fourth will end, or multiples of 4 will end in the last column. So 4, 8, 12, 16, 20, 24, and so on. So whenever you are dividing all this number by our rule, you will get 0 as the remainder. But instead of 0, we need to consider it as 4. So I hope it is clear. All right. So anybody have any doubt, you can chat with me. I'll reply. I'll look at it. So far, so good. I'll wait for 1 or 2 minutes. All right. So let's move on then. So very first question. Today we are just discussing the concepts along with the questions. So the first one, how many prime numbers are there between 10 and 50? Like you know, prime numbers are those numbers which are divisible by 1 and itself. Divisible by 1 and itself, right? So how many prime numbers are there between 10 and 50? Let's count quickly. 11, 13, 17, 19, 23, 29, then 31, then 37, then 41, 43, and 47. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer is 11. All right. Now you can expect this question as come in direct way also, because here you really don't need to use pen and paper only. Okay. You can just do it by yourself also, just by applying little logic to it. And I insist for every question, try to think in head first, and then you pick up pen and paper. Okay, so we'll move to the next one. How many multiples of 23 have between, how many multiples does 23 have between 116 and 253? So how many multiples does 23 have between 116 and 253? So if I see this, 23 into 5 will give me 115, right? So before 116, there was one number 115, which was multiple of 23. Okay. Try to understand this. I am trying to explain you in a little logical way rather than in some direct like multiplication and other thing. We'll do it in a logical way. I don't remember whether I told you this yesterday or not, but if we have to multiply number by 11, So what we will do, we'll write 2 as it is, we'll write 3 as it is, and in center we'll add these two number. So 23 into 11 is nothing but 253. Let's look at one more. If you have to multiply 62 into 11, 62 into 11 will be what? I'll write 6 as it is, I'll write 2 as it is, and 6 plus 2 is what? 8. So 682. 682 will be my answer. Now let's take one more where there is a carry forward. So if I have to multiply 87 into 11, all right, 87 into 11, I'll write 8 as it is, I'll write 7 as it is. Now 8 plus 7 is what? 15. 5, 1 will be carry forward. 1 will be carry forward. So your answer will be what? 957. Okay. Now looking at this 253, I know that this is nothing but 23 into 11, right? But they're saying have in between 116 and 253. So I don't have to take 253. I have to take a number before 253, which is divisible by 11. So if it 23 into 11 is here, it means that before 253, it is 23 into 10. All right. 23 into 10. Yes or no? So 115 also I cannot take because again they are talking about between. So 23 into 5 is 115. So I'll write it here. 23 into 5 is 115. I cannot take this. Now can I say 23 into 6? Some number will be there. And then 23 into 7, some number will be there. 23 into 8, some number will be there. 23 into 9, some number will be there. 23 into 10, some number will be there. Now 23 into 11 is 253. But I need to take somewhere number between 116 and 253. So I should not take 253. I should not take 116. So can I say these all 5 numbers would be there? So my answer will be 5. All right. I'll repeat quickly. We know that 23 into 5 is 115 and 23 into 11 is 253. So basically 23 into 6, 23 into 7, 23 into 8, 23 into 9, 23 into 10. This all number will be there between 116 and 253. Between 116 and 253. If I have to do it quickly, I will not write and waste my time. I will not waste my time writing this 23 into 6, 23 into 7 and so on. I just know 23 into 5 is 115, 23 into 11 is 253. So there will be 5 multiples, 6, 7, 8, 9, 10. So the answer will be what? 5. So I hope it is clear. Okay. So let's move on then. Once again, people, in case I can see that chat is not, there is some problem in chat, unable to chat, something like that. So there is one email ID which I have shared with you yesterday also. Today also I'll share it with you. It is step learning solutions @gmail.com. Right? You can always post your query on this. One of the students had sent yesterday some of the queries, 2 queries. We have received those queries, but we will discuss those queries when the topic will be there. So we are going to discuss that. Still, if you want to discuss that, let me know today again in that email and we will take it in one of the live classes. Fine. So let's move on. Let's move on. Okay, this is fairly simple. Find the value of 3 plus 6 into 12 by 3. I'm giving some time for you people to solve. Let's take few seconds. Fairly simple. Okay, I hope you would have got the answer. We need to use Bodmas rule, where B stands for bracket, O stands for off, D stands for division, multiplication, addition, subtraction. So division, will divide this first. So this will become 4. So 6 into 4, 3 plus 6 into 4 will multiply. 6 into 4 is 24 plus 3. So the answer is 27. All right. Okay, let's move on. Fine. So let's x, y, z to be distinct integer. X and y are odd and positive, and z is even. Which of the following statements cannot be true? Cannot be true. X and y are what? Positive. Positive and odd number. So take some number. Let's say 7 and 5. And z is even. So take it as 2. Why we are taking x and x as greater and z is smaller? Because everywhere we see it is x minus z. All right. So that's why we are taking x as 7 and z is 2. So let's substitute the value. 7 minus 5. 7 minus 5 is, sorry, 7 minus 2. 7 minus 2 is 2. 7 minus 2 is 5. Now I'm not sure whether it is square or it is into 2. So let's look at with both. If it is 5 square, it will be odd. It is odd, and 5 square will be odd, and 5 square into y, which is again odd. So odd into odd will be odd. They're saying cannot be true. So as of now, let's keep it into check. Now second one, x minus z into y square is odd. Yes, this is true. This is true. X minus z into y. So we know x minus z is 5. That we have considered 7 minus 2 as 5. 5 into odd number. So odd into odd is odd. This is also true. Now x plus y. Odd plus odd. Odd plus odd is what? Even. Odd plus odd is even. Now even cube is also even, and even into even is also even. So this is also true. The question is asked about cannot be true. So cannot be true. The first one will be our answer. Okay, just substitute the value. This is into 2 only. Into 2, 5 into 2, 10 into, yeah, this is square, people. This is square. Okay, it's not into 2, it's square. Power. So the number is like x minus z whole square into y is even. That's the given condition. Otherwise, all the options will become true. Will be true. So they are asking which cannot be true. So that would be your answer. Fine. So let's move on. Okay, give a try. Read this question once. Now in this type of question, go with the option. So 7 plus 7 plus 3. First condition is that the sum of the digits of 3-digit number is 17. So we'll see how many numbers addition is 17. 7 plus 7, 14 plus 3, 17. Okay. 6 plus 8 plus 3, 14. Okay. 9 plus 4, 13 plus 4, 17. 8 plus 6, 14 plus 3, 17. So this first condition is not helping us, right? Now the second one, the sum of the squares of its digit is 109. So let's see the squares. 49 plus 49 plus 3. We should get 109. Focus on unit digit. 9 plus 9, 18. 18 plus 3 is 21. Option eliminated. I repeat, they are saying the sum of the squares of its digits is 109. So when I add 49 plus 49 plus 3, I'm just focusing on unit digit. I need 109. I need 9 as unit digit. So 9 plus 9, 18 plus 3, 21. This option eliminated. Let's check this one. 6 square is 36, 8 square is 64, and 3 square is 9. Make sense? 36 plus 64 is 96, and 8 square is 9. Make sense? 36 plus 64 is satisfying. Second condition, no. We shall get the number. We subtract 495 from this. If we subtract 495, we shall get the number consisting of same digits in the order in the reverse order. So if it is 683, we should get 386. Are we getting 386? Do you think so? 13 minus 5 will give you 6 at the unit place? No. So this option also got eliminated. But if I look at option D, has same digits, it means that this will also satisfy 109 for sure. Now, if I take 863 minus 495, so 13 minus 5 is 8. So I should get 368. I should get the reverse of the digit, and I'm getting that. We can finish it off quickly. 15 minus 6, 15 minus 9 is 6, and this is 7 because 1 will carry forward. 7 minus 4 is 3. So you are getting this. It means that answer is 863. When you will do it by yourself, keeping all the conditions in the mind, this question can be done quickly also. As of now, I'm explaining to you. That's why it is taking little more time. All right, just focus on here. 773, addition of the digits is not giving me 109. Ignore it. 683, additions of the squares of the digits is giving me 109. This could be my answer. Could be, I'm not sure. Now another condition they are saying when subtracting 495. So if I take 683 minus 495, 13 minus 5 will not give me 6. I should get 6 here. 13 minus 5 is not giving me 6. Option eliminated. If I take 863 minus 495, 13 minus 5 should give me 8, or it is giving me 8. Yes, that's my answer. Okay, so we'll move on. I hope it is clear. Let's move to the next one. A whole number with n which when divided by 4 gives 3 as the remainder. So what number will give you 3 as the remainder? I can say 7. So let's say n is 7. If n is 7, what will be the remainder when 2n is divided by 4? So 2 into 7 is 14. So when 14 is divided by 4, my remainder will be what? 2. So the answer is 2. Now I'll use pen. They're saying the whole number, a whole number n, which when divided by 4 gives 3 as the remainder. So n, which when divided by 4 gives 3 as the remainder. So what this could be? Take any number. You can take 15 also. 15 divided by 4. It will give you 3 as the remainder. Yes. Now, double of 2. Let's take 2 examples. 7. And when we divided 7, that time also we got 3 as the remainder. So we'll take n is equal to 7 and 15. Let's check quickly. 2n will be 14 and 30. So when 14 is divided by 4 again, 4, 3, 12, your remainder is 2. 30 is divided by 4 Again, your remainder is what? Your remainder is 2. So finally, your remainder is 2. All right. So I hope that's clear. So try to solve some questions orally also. Tomorrow, when we will do the revision of this topic, we will try to solve as many as question orally. Today, we will use pen and paper. Fine, let's move because we have to get ready for the worst. In case if they don't allow at the end moment, we should not get panic at the last moment. So our preparation should be in such a way. All right, fine. 576x45 is divisible by 9. What is the maximum number of values that x can take for any value of y? So what is divisibility rule of 9? We have already discussed divisibility rule of 9. So divisibility rule of 9 is sum of the digits should be divisible by 9, right? Sum of the digits should be divisible by 9. So if I'll add 5 plus 7 plus 6 plus 5 plus x plus 4 plus y, this is plus. So 5 plus 7, 12 plus 6, 18, 18 plus 5, 18 plus 5, 23, 23 plus 4, 27. So 27 plus x plus y, all right? What is the maximum number of values that x can take for any value of y? If y is 0, then x can be what? 9, right? Because 27 plus 9 will be divisible. Yes or no? Okay. And if y is 1, x can take for any value of y. If y is 1, then it has to be what? It can be 8, right? Now they're saying for any value of y, if it is 0, it can, see, for 1, it will be taking 8 only. For 2, it will be taking 7. For 3, it will be taking 6. For 4, it will be taking 5. For 5, it will be 4. For 6, it is 3. For what it is 7. For 7, it will be taking 2. For 8, it will be taking 1. And if it is 9, it can take 0. Right? Now, if it is 9, it can also be 9. Because if it is 9, and if you're taking 9 here or 0 here, the number will be divisible. If you're taking 0, so this can be 9 or this can be 0. So now you see their question, they are asking number of values that x can take for any value of y. So if you take 9, you can take what value? 9 or 0. If you're taking 0, then you can take what? 0 or 9. If you're taking 1, it is 8, like 1. For one value of y, you are able to take only one value. For 2, you are able to take only 7. For 3, you are able to take only 6. Right? So maximum how many values of x you are getting here? Everywhere it is 1, 1, and these two places there are 2 also. So can I say maximum number of values that x can take is what? 2. I repeat, basically the question is asked about how many this number 576 plus x plus 4y should be divisible by 9. Now we have discussed divisibility rule of 9. Divisibility rule of 9 was rule of 9. Sum of the digits should be divisible by sum of the digits should be divisible by 9. Should be divisible by 9, right? So when I add all this, I'll get 27 plus x plus y. So if I take 27, if I'm taking x value as 0, y value could be 9 or it is 0. It will be divisible by 9. It will be divisible by 9. If I am taking y value, okay, we have to take for y value. So let's take, if y is 0, then x value could be either 0 or 9. 27 plus 9 is divisible by 9. 27 plus 0 is divisible by 9. If y value is 9, then again x value can be 9 or x value can be 0, right? Because 27 plus 9, the number will be divisible by 9. 27 plus 0 plus 9, still the number will be divisible by 9. But now when I proceed, 27 plus, if I'm taking y is equal to 1, x has to be 8. So x is taking only one value. If y is 2, x has to be 7, and so on, whatever the numbers I have written here. So maximum number of values that x can take is what? Maximum it can take 2 values. All right, so the answer is 2. I hope it is clear. Okay, so let's move on then. So we are good with this. Let's move to the next one. If 122 122x, where x is a single digit whole number, is divisible by 4, how many values x can have? Again, divisibility rule of 4. So we have discussed in the beginning of the session also today, we have revised it, that divisibility rule of 4 says last 2 digits should be divisible by 4. So last 2 digit, where x is a single digit number. So if it is 1, 2, 2x, we just have to focus on this 2. So 2, 0 is divisible, 2, 4 is divisible, 2, 8 is divisible. So these are the 3 possible values of x we can take. How many values of x can have? X can have 3 values. All right, let's move on. How many 3-digit numbers are divisible by 4? Now, how many 3-digit numbers are divisible by 4? What would be the answer for this one? How we'll solve this? 3-digit number. So 3-digit numbers will be up to 999, right? And again, out of this, I'll say 996 will be divisible by 4. So from, let's do this one, from 1 to 996. How many numbers total? Total numbers divisible by 4. Total numbers divisible by 4 will be how many? We need to divide 996 by 4. You will get what? 428, 1, 4, 416, 3, and you will get 9. That is 36, and here you will get 9. So you are getting 249 numbers. All right, 249. So now 1, 2, 3, so on up to 92, 96, 100. So from here, 3-digit numbers will start. 100, 104, 108, so on up to 992, 996. All right. So when I look at this entire thing, I have 249 numbers which are divisible by 4. I need numbers from this part to this part, right? How many numbers will I have from this part to this part? Now I know that 4 into 25 is 100. So can I say 24 numbers would be there? Because what I'm doing, I'm dividing 96 by 4. 96 by 4, 24 into 4 is 96. So this is giving you this overall this number. There will be 24 multiplications of 4. 24 numbers will be there, which are multiples of 4. So 24 this, and in total we have 249, right? So what should I do now? I should subtract this numbers from 249. I should subtract 24. So 249 minus 24. 9 minus 4, 5, 2, 2. So how many numbers you got? You got 225. Again, if I have to do it orally, I'll directly go with like 996 divided by 4. Even if 249 is a problem, I know when I divide 100 by 4, I will get 25. So when 1000 is divided by 4, it means that it will be 250. But I need to see before 250. So, sorry, I need to see before 1000. So before 1000 is 996. It means that it will be 249. So 249 number overall. And first two digit numbers, which I have to subtract. So two digit numbers are 24. Two digit numbers which are divisible by 4, I need to subtract that from the total. So two digit numbers which are divisible by 4 are 24. So that's why 249 minus 224. You will get 225. Okay, people keep thinking, like, don't go into when I'm saying it. Please understand that we need to be prepared for the worst. Hope for the best, prepare for the worst. Okay. Right, let's move to the next one now. I hope that's clear. I'll still wait for another 20 seconds so that you can look at it. Okay, I hope 20 seconds over. So we'll move. Okay, we have discussed this yesterday. What is the unit digit of 3 to the power 33? We have discussed this already. 3 to the power 33. What is the first step? Okay, try quickly. I'm waiting for your answer. You to get your answer. Okay, done. 3 to the power 33. Very first step, divide this last two digits of power by 4. 4, 8, 32. Remainder is 1. Take this number itself or unit digit of any number to the power remainder. Remainder is 1. 3 to the power 1 is 3. So that's your answer. That's it. In the beginning of this session, I have written the rules. So in case if anybody is joining now and is unable to understand, please go through the beginning of the session. You will understand. I have written 4 steps how to find out unit digit of a number. Very first step, divide the last two digits of power by 4. Focus on remainder. Take the unit digit of given number to the power remainder. That will be your answer. Okay, let's move to the next one. All right, so this is a little extended version of the previous question. 2 to the power 47 plus 7 to the power 13. Fine. Take another 20 seconds. Try to finish it off. Okay, so I hope you would have got the answer. I'll tell you how to find out remainder so quickly. When you are dividing it by 4, 48, I know 48 is divisible by 4. Or if I say, yeah, so what I can say, if you compare it with respect to 10, right? So 10 is not divisible by 4, 20 is divisible, right? 30 is not divisible by 4, 40 is divisible. 50 is not divisible by 4, 60 is divisible. So when 50 is not divisible by 4, it means that two numbers before 50 would be divisible. Same way, like 10 is divisible by 4. Sorry, 10 is not divisible by 4. 10, I should write it this way. 10 is not divisible by 4, but two numbers less will be divisible by 4. Will be divisible by 4. So keeping that into const by 4. Keeping that point into context, so I know 50 is not divisible by 4, but 48 will be divisible by 4. So 48, 47, it means that 1 will be the remainder. Go back. Or else if I'm not, whatever I'm saying, if I'm not making sense, you directly divide. So 4, 11, 1 minute, people. I'm sorry. So 4 into 11 is 44. 3 is the remainder. 2 to the power 3. 13 divided by 4. Your remainder is 1. 4, 3, 12. 1 is the remainder. So 7 to the power 1. 2 to the power 3 is 8. And 7 to the power 1 is 7. 8 plus 7 is 15. So the answer is 5. Answer is 5. All right. So let's move on. Simple one. Okay, so let's move it. Fine. Now, what is the LCM of 12? You used to solve LCM maybe in this way, 12, 16, 30. Let's get emotional. 2 ones are 2, 2 6 are 12, 2 8 are 16, 15. 2 3s are 6, 4. If this will not go, okay, then you will again 2 2 15, 2 3 2 1 here and 15, and then you have 3 1 1 5, and then you have 5 1 1 1, and then you will multiply all this 2 into 2 into 2 into 2 into 3 into 5, right? Now this is one way. What is this? 2 2 4 8 16, 16 into 5 18 into 3 480. 480 is the answer. Now how I will do it, or like the way we should approach is 12 16 30. Listen carefully. 12 16 30. I repeat, 12 16 30. Which is the largest number? We need to look for the largest number. 30. So 30. Is 30 divisible by 12? Is 30 divisible by 12? Is 30 divisible by 12? No. So 30 cannot be your answer. Go to next multiple of 30, 60. Is 60 divisible by 12? Is 60 divisible by 12? Yes. 60 is divisible by 12. But is 60 divisible by 16? No, right? So that's why 60 also got eliminated. I hope you are getting my point. So 30 is not divisible by 12. 60 is divisible by 12. But now, instead of focusing on, I think 240 could be your answer. 16 into 5 is 80, 80 into 3 is 240. Yeah, 240 should be your answer. Now 60 is here. Check again. 120 will be divisible by 16. Sorry, 120 is divisible by 12, but 120 is not divisible by 16. All right, 16 into 10 is 160, and 16 into 5 is 80. So it is not divisible. Now go to multiple of 120. You can look for 180 also. See what we are doing? We looked for 30. 30 is not divisible by 12 and 16. We eliminated. Then we looked for 60. 60 is divisible by 12, but not divisible by 16. So now we will consider the multiples of 60. So we'll take 120. 120 is divisible by 12, but not divisible by 16. 180 divisible by 12, but not divisible by 16. Next one, 240 divisible by 12 and divisible by 16 also. Okay, 16 into 15 is 240. I hope it is clear. We'll do one thing, we'll take some simple number. Some simple numbers will be, could be what? Okay, let's practice for you. 236, a very simple one. 236. Let me see if I have any blank sheet. Okay, anyway, let's do it here only. 236. 6 is the largest number. Is 6 divisible by 2? Yes. Is 6 divisible by 3? Yes. So 6 will be LCM. Let's take another number. 5, 10, 20. Is 20 divisible by 5? Yes. Is 20 divisible by 10? Yes. So 20 will be the LCM. Let's take some different number. 8, 18, and 20. 8, 18, and 20. What is the largest number amongst them? 20. Is 20 divisible by 8? No. Is 20 divisible by 18? No. So let's move on. 20, I'll check for 40, not 40 is divisible by 8, right? 40 is divisible by 8, but is not divisible by 18. So now let's move to the multiples of 40. Multiples of 40 could be what? 80, not divisible. What else it could be? 80 and then 40, 80, 140, right? 120. Is 120 divisible by 18? No. 160 divisible by 18? No. So now one more thing you can do is 18 and 20 LCM will be 90, not 90. 9, 18 into 5 is 90, and this is some 180. These two numbers are very close. So this will go little lengthier. Rather than shortcut, it will become long cut. So we need to look at the numbers also then, how the numbers will be. 8, 18, 20 are, like 18 and 20 are very close number. 18 and 20 LCM will be 360. 18, or you can say 180 also. Right. 180. 180 will be the LCM of between 18 and 20. And now we need to think about 8 and 180. Common factor of 8 and 180. 8 and 180. So this is what it could be. 180. There should be a shortcut for this also. 188. This is 2 into 2 into 2. No, this will be lengthier. This will go little lengthier. Fine. I'll do one thing. Tomorrow when we will do the revision, I'll get back on this question again. I'll find out the shortcut for this. I'll work out on few more questions so that you can find LCM pretty quickly. Okay. I don't think so we should use this method, or else you can go ahead with from the options also. As we don't have options here, you can just use, if we have options, we can go ahead with the divisibility rules also. We can check that. Fine, I'll get back to you on this. So let's move on as of now. Okay, HCF, highest common factor. I repeat, people, I will get back to you on this tomorrow. We will discuss LCM. I'll just look for one more shortcut, because the shortcut which I told you is working on few numbers. There should be a shortcut which can work on other numbers also. So I'll get back to you. Okay, I'm sorry for this, but I'll get back to you tomorrow. Okay, so the next one. What is the HCF of 39, 117, and 1001? Now, the options which we'll look at here is 3, 39, 11. So check. Is this number divisible by 11? Is 39 divisible by 11? No, right? So 39 is not divisible by 11, option eliminated. This option eliminated. Now it is what? 13 into 3 into 13. 13, 3, 39. All numbers are kind of familiar. Like 13 into 3 is nothing but 39. So let's see. 39 could be written as 13 into 3. 117 is also a multiple of what? Is it a multiple of 13? 117 could be written as 13 into 9 is 117. Okay, 13 into 9 is 117. And this can be further written as 13 into 3 into 3. We need to look for highest common factor. So as of now, it is 13, 3, 13, 3. Now for 1001, so 1001 also will check with 13 first. 13, 6, 7, 91. 13, 7 is 91. So 9 will be carried forward and 91. So this is 77. So this can be written as 1001 can be written as 13 into 77, where this 77 could further be written as 7 into 11. So which is the highest common factor you got? That's 13. So 13 will be your answer. Okay. One more thing I could have done here is a highest common factor of this, right? The way I have eliminated 11, that 39 is not divisible by 11, I can check, is 39 divisible by 3? Yes. Is 117 divisible by 3? Yes. But is 1001 divisible by 3? No, right? I hope you're getting my point. So 1003 is also not divisible by 3. So this option also got eliminated. Now we're left with 13 and we left with 39. So 39 was here, 39 was here. For 1001, we checked it, we got 30. Fine. So let's move to the next one. Okay. So the next one is LCM of fraction. So LCM of fraction is equal to LCM of numerators upon HCF of denominators. So when I have to take LCM of 5 by 3, 6 by 7 and 3 by 5, what I'll do, I'll take LCM of 5, 6, 3. Okay, I'll take the LCM of 5, 6, 3 and I'll take HCF of 3, 7, 5. So 5, 6, 3. Which is the largest number? 6. Is 6 divisible by 3? Yes. Is 6 divisible by 5? No. So when the numbers are prime number, you can do directly multiply. 6 into 5 is 30. Directly multiply. 6 into 5 is 30. And HCF, highest common factor of 3, 7, 5. 3 into 1, 7 into 1, 5 into 1. So 1 will be highest common factor. So this will be 30. Your answer is 30 by 1, 30. Similarly, in case if we have to calculate HCF of fraction, HCF of fraction is equal to HCF of numerator upon LCM of denominator. Okay. HCF of numerator upon LCM of denominator. So in case if we had to calculate HCF of the same fraction, 6 by 7, 3 by 5, what we would have done? We would have done HCF of 5, 6, 3 and LCM of 3, 7, 5. Again, HCF of 5, 6, 3 would be 1 and LCM of 375. Now all are prime numbers. You see, all are prime numbers. So whenever the numbers are prime, you directly multiply to it. So 3 into 7, 21, into 5 is 105. So your answer is 1 by 105. What is this? This is HCF, HCF of fraction. Fine. Okay, let's move on. Fine. So now this one, LCM of 36, 42 and x, where x is a natural number, is 252. What is the maximum possible value of x? LCM of 36, 42 and x is a natural number, where x is a natural number, is 252. So LCM of this is 252. 252. We need to calculate the maximum value of x which is possible. All right, when they're saying what is the maximum possible value of x, right? From the options, the maximum number is what? 252. Now, if I take 252 here, what I need to check that is 252 completely divisible by 42. Like, let's say a number 8, 10 and x. And the options for x are 40. Options for x are same question 8, 10x. Options for x is 80. First option, second option 40. Third option, could be what? 160. And fourth option could be 200. So now 200, and it is given that LCM of this number is 160. LCM of this number is 160. And we need to see the biggest number. So when we need to see biggest possible value for x, can it be 80? If it is 80, then LCM will be 80. LCM will not be 160. All right. But whereas they are saying the maximum possible value of x, look for the maximum number, right? Out of this maximum number is 200. But when you look at 200, 200, 8 and 10, all right, 200, 8 and 10, LCM will be 200. LCM is not, LCM will be 200. LCM will be 200. So LCM will be 200. LCM will be 200. But in a simple way, we can say that if their natural number is 252, if they what it could be that x is nothing but the number itself. All right, like here 8, 10x. If they would have given that LCM is 200, so the x value will become what? 200. If it is given LCM is 160, so x value will be what? 160. So here also in a similar way, if it is 252, let's take 252. And moreover, from the option, we just see 252 is the maximum possible value. So 252. Now the numbers here were easy, 10 and 8. We know that it's quite divisible. But when you look at this, you need to divide this number. So go with the possibility. Like 2 into what number will give you 2 at unit place? 2 into 6 gives you 12. So multiplied by 6. 6 to 12, 6 4 24 plus 1, 252. So yes, 252 is divisible by 42. 36. 6 into what number will give you 2 at unit place? 6 into what number will give you 2 at unit place? 7. 36 into 7, 7, 6, 42, 4, 7, 3, 21 plus 4, 25, 252. Yes, so the answer is what? 252 itself. Moreover, you can do it directly. Whatever the number is given, like I have given you few options here. If LCM is given 200, X value would be 200 because 200 is divisible by 8 and 10. If LCM is given 160, 160 will be the direct answer. All right. So keep this question in mind in case if it is a direct question, you can do it. Fair. Let's move on. All right. So if S is the sum of the digits of LCM of 8, 12, and 36, what is the value of S? I would like you to try. Just try once quickly. So LCM of 8, 12, and 36. So is 36 divisible by 8? No. Is 36 divisible by 12? Yes. So let's move to multiple of 36. Next number is 72. Is 72 divisible by 8? Yes. Is 72 divisible by 12? Yes. So 72 will be the LCM. LCM is 72 and the sum of the digits will be equal to what? 9. So the 9 is the answer. I hope you would have got it. Fine. Let's move to the next one. If the product of two natural numbers is 144 and their HCF is 4, what is the LCM of the two numbers? So there is one direct property. LCM into HCF is equal to product of two numbers. I repeat, LCM into HCF is equal to product of two numbers, A into B. All right. So LCM is, we don't know. We need to find out LCM. HCF is 4 and product of two number is given 144. So basically LCM is what? 144 divided by 4. 144 divided by 4, 4, 3, 12, 2, 36. So answer is 36. I hope my speed is fine. If you want me to increase or slow down my speed, please let us know in the comment box or in chat. So there are some people who are joined. Okay. All right. So the next one. So the next question is this. Yeah, so again, this type of question, you can do it orally. What is the smallest number which when decreased by 8 is divisible by 21, 27, 33, and 55? So how you should solve this type of question is, they are saying the number should be divisible by 8. Oh, sorry, when you decrease that number by 8, it should be divisible by 21. It should be divisible by 27, 33, 55. So basically that number should be divisible by 3 also. It should be divisible by 3. It should be divisible by 7. It should be divisible by 9. It should be divisible by 11. And it should be divisible by 5 also, because 55 and 11. So very simple way. If the clue here is the number should be divisible by 5 too. When I decrease all these numbers, I should get 5 at, when I decrease all this number by 8, I should get 5 at unit place, right? Because there is condition given is divisible by 21, 27, 33, 55. Forget about all number. It should be divisible by 55. If it should be divisible by 55, it means that it should be divisible by 5. So now 1490 minus 8 will give me 2 at unit place. Option eliminated. 10405 minus 8 will give me 7 at unit place. Option eliminated. 15490, again 15490 minus 8 will give me 2 at unit place. Option eliminated. 10403 minus 8, right? 10403 minus 8. Will it give you answer? 13 minus 8 is 5, right? I need 5 at unit place. Wonderful. Let's solve this. This will be 9310395. So this will be my answer. You can just check for this. If you want to check the divisibility rule of 11 also, 1 plus 3 plus 5, 5 plus 3, 8 plus 1, 9, and 9 plus 0. It is divisible by 11. Is it divisible by 3? 1 plus 3, 4 plus 5, 9 plus 9, 18. It is divisible by 3, 9, 11, 5. It will be divisible by 7 also for sure. I'm just doing it. You don't have to do it. Once you get this 5, you can just go ahead and mark it. But just to do the divisibility rule of 7, I'm doing it quickly. What we do, we'll multiply the unit digit by, we will double the unit digit, that is 10, and then we subtract it. So you will get 1029. Again, we'll double this and divide, subtract. So 9 into 2, 18. 12 minus 8 is 4. 9 minus 1 is 8. And this. Again, I don't know, but I'll double this. 4 into 2, 8. 18 minus 8. I think I'm making a mistake here. 5 to 10. So this is 2. 9 to 18. 12 minus 8 is 4. And this is 9. 9 minus 1 is 8. And this is 1. Where I made a mistake. This is 9. Oh, yeah, here it is. 102 minus 18. 1029. So this is 2. 9 to 18. So 12 minus 8 is 4. And 9 minus 1 is 8. 84. 84, you got it. It means that it is divisible by 7 also. Right? I wrote this one extra, whereas it was only 84. Fine. You don't have to do all this circus. What I have done, you simply have to stop it here. Once you get 5, you just need to mark and move ahead. Okay, let's move ahead. Fine. This is another question on LCM. So 3 bells chime simultaneously at 12 noon. If they chime at intervals of 4 minutes, 8 minutes, and 12 minutes respectively, at what time will they chime together the next time? So one chimes at 4 minutes, another one at 8 minutes, and the next one is at 12 minutes. 4 minutes, 8 minutes, 12 minutes. So this one, 4, will 8 will chime at 8, 12, 16, 20, 24, 28, 32, and so on. This one will chime at 16, 24, 32, and so on. And this one will chime at 24, 48, and so on. So can I say at 24th minute, this bell is also chiming, this bell is also chiming, and this bell also chiming. So can I say after 24 minutes they will chime, right? Which means that at what time will they chime together the next time? It is first time they chime together at 12 noon. So after 24, what time will they, after 24 minutes, they will chime at 12:24. Okay, they will chime at 12:24. Now what we are doing, this 24 is nothing but LCM of 4, 8, 10, 12. Whatever the timings been given, we just need to take LCM of that timing. So LCM of 4, 8, 12 is what? 24. So Answer is 24. Okay. Whenever the question is about a circle, what time, if they have started, one is running, let's say there is a circle and one is completing a circle in 5 minutes, another one is completing in 15 minutes, and the third person is completing it in 20 minutes. If they have started together, when will they meet again at the same time? So in such type of question, we need to calculate always LCM. There could be one more question, like a guy is going from point A to point B, and there are traffic signals. There are three traffic signals. One gets green after every 20 seconds, second gets green after every 40 seconds, and third gets green after every 60 seconds. So I repeat, traffic signal, one gets green, traffic signal, one gets green after 20 seconds, next one gets green after every 40 seconds, another one gets green after every 60 seconds. At what time, or like, yeah, after how many seconds will all the three signals be green? After how many seconds will all the three signals be green? We need to take LCM of 20, 40, and 60. Okay, 20, 40, 60, LCM is 180. So 180 will be the answer, 180 seconds. No, 180 is not divisible by 40. 240 seconds. Or it could be 120 also, actually. 120 seconds will be the answer. 120 is divisible by 20, divisible by 40, divisible by 60. Okay, so it is 120 seconds. Done? Fine. Let's move on. Okay, so this is a good question. I want you to try. Just now we have discussed similar one. Try once. In 30 minutes, how many times they toll together? So again, first bell is ringing after every 2 seconds, 4, 6, 8, 10, 12. So I need to take LCM of this. LCM of 2, 4, 6, 8, 10, 12. Now the largest number amongst them is 12. And 10 is also there. So it has to be a multiple of 10 and 12. Like I can take LCM multiples of 12, 24, 36, 48. But all these numbers will not be divisible by 10 for sure. So what I'll do, I'll directly move to 12 into 5, 60. Is 60 divisible by 2? Yes. Is 60 divisible by 4? Yes. Is 60 divisible by 6? Yes. Divisible by 8? No. 60 is not divisible by 8. So now I'll move to next multiple of 60, that is 120. Is 120 divisible by 8? Yes, 15 into 8 is 120. So 120 seconds. 120 second means what? 2 minutes. So after every 2 minutes, it will toll. So in 30 minutes, it will toll together for how many times? 15 times. 30 minutes, 30 by 2. 15 times, right? But the answer is 60 because they are asking in 30 minutes how many times they toll together. So let's say if they have tolled together at 6 o'clock. Now this will be counted as 1. At 6:02, it will be counted as twice. At 6:04, it will be counted as 3. So on up to 6:30. So when you see this, we had counted 2 minutes everywhere. So that's why we are getting 15 times. But we need to talk about initial one also. So hence the answer is 16 times. It is very close call. Many students earn marks 15, and that's where they do give such type of options where you can go ahead with, like, where you can get confused easily, but just pay attention to the question. Okay, so it is 60, not 15. After every 2 minutes, it's tolling together. So in 30 minutes, it will toll for 15 times. But in the beginning also, they would have tolled together. So that's why it is 16. Fine, let's move on. So what is the sum of the digits of 7 factorials? Sum of the digits of 7 factorial. 6 factorial, 5 factorial is 120. 6 factorial is 120 into 6, that is 720. And 7 factorial is 720 into 7, right? So which is 5040. So the summation of the digit is what? 9. 9 is the addition of the digits. 5 plus 4, 9. Okay. So I hope it is clear. What do you want me to repeat? Patricia, you can let me know what you want me to repeat. I'll wait for, because there is one query, so then I'll move on. Question number 30. Okay, okay. So when you see this, 1 minute. It is 1 factorial is nothing but 1. 2 factorial is what? 2 into 1. So, okay, you can do one more thing. 7 factorial is nothing but 7 into 6 into 5, 4 into 3 into 2 into 1. Okay, just multiply all this. So 1 into 2, 2 into 3, 6, 6 into 4, 24, 24 into 5, 120, 120 into 6, 720, 720 into 7 is 5040. I'm sorry, I considered that you might know the value of 5 factorial. I'm sorry. So 7 factorial is nothing but 7 into 6 into 5 into 4 into 3 into 2 into 1. So multiply it from the reverse. You can multiply from the forward also, but the multiplication will be larger. So 1 into 2, 2 into 3, do this way, you will get 5040. I hope it is clear now. Right? Okay, so we'll move on. All right, so let's move on. This one we will not get time today, so we'll discuss tomorrow. This is little lengthy topic, factors, and I don't think so it is important also with respect to IND SAT exam, but we will discuss tomorrow. Okay, I don't want to leave any topic, because in case if it comes from this topic, then you should be able to solve. So as of now, which of the following numbers are divisible by 3 but not by 9? I hope you can do this. So 9 plus 3 is 6 plus 3 is 9 plus 9. No, this cannot be your answer. 2 plus 3, 5 plus 4, 9 plus 3, 12. This could be your answer. 36, directly I can see that it is divisible by 3 and 9 both. Option eliminated. 9, 3, 6. 9 plus 3 is 12 plus 6 is 18. Divisible by 3 and 9 both. Option eliminated. Now when I have to choose between these two, I'll choose the smaller one. 2 plus 3, 5 plus 4, 9 plus 3, 12. Oh, 12 is only divisible by 3, not by 9. So hence this is your answer. Fairly simple one. Okay, so what is the largest 4-digit number? Exactly divisible by 88. Exactly divisible by 88. What we need to do? We need to break the number. Okay, how will we do that? How will we do that? 88. 88 can be written as 8 into 11. 8 can be written as 2 into 4 into 11. It means that number should be divisible by 11. Number should be divisible by 4, right? So this option got eliminated. Now the rest of the numbers are divisible by 11 for sure. You see, 9, 4, 9, 4. 13 minus 13 is equal to 0. This number is divisible by 11. Divisibility rule of 11 I'm using. 9 plus 8, 9 plus 8. 17 minus 17 equal to 0. If you see this 9 and 9, this will also be divisible by 11. Now all the numbers are divisible by 4 also. Okay, because this is 4 divisible by 4, this is divisible by 4, and this is also divisible by 4. But instead of checking for 4, you check the divisibility rule of 8. Check the divisibility rule of 8. What is the divisibility rule of 8? Last 3 digits should be divisible by 8. So let's check. 944. Is it divisible by 8? 818. Actually, 812 is 96. 811 is 88. 64 is divisible. So this is divisible. Let me quickly check. Now, when I compare these two, 9944 and 900, I need to look for the largest. So I'll eliminate this. Why am I eliminating? Because 9900 is smaller than 944, 9944. So anyway, I got the bigger number. So I'll not check this. Now between these two, I'll check quickly. 988 also. 8, 12 is 96. 2 is the remainder. 28 is not divisible by 4. So this option gets eliminated. Hence, this is your answer. I repeat, the options were 9944, 9988, 9900, and 999. So number has to be divisible by, the number has to be divisible by 88. It means that it has to be an even number. So that's why we eliminate this option at first. Now all the options are divisible by 11, because if you go by alternate rule, some of the digits at alternate places, and the subtraction, because at alternate places it's the same digit. So it is working. So out of these two, if I look at this, these two numbers are bigger than this one. So this will be my last option, because they are talking about the largest. So this will be my last option. I'll check out of these two, which one is divisible by 8. So if I check this, I got that this is divisible. So once again, I confirm for this. Or you can take the largest number only directly, 9988, and divide it by 8. You will get remainder as, okay, I just have to take the last 3 digits. So when you take the last 3 digits, it will be 96, 28. 28 is not divisible by 8. This option get eliminated. So out of this, okay, better you check it only. So 2 times you check and you will get the answer. All right. So this is the answer, 9944. Break the number and get it done. All right. So fine. I want to discuss one last concept and then we'll come to all these other questions. So we'll do one thing. Quickly, we'll discuss one more concept and then we'll come to the remaining question. So one thing I want you people to understand is remainder theorem. Okay, a very simple one. You will find the question can also be solved very simply. So when 6 is, all right, let me take this way. When 7 is divided by 6, when 7 is divided by 6, what is the remainder? What is the remainder? 1. 1. When 7 is divided by 6, what is the remainder? When 7 to the power 23 is divided by 6, what is the remainder? It is still 1. Why? Because how I'll solve this part now, 7 to the power 23 by 6 is nothing but 7, how many times? 23 times. And by 6. So now I am finding out remainder. When I am finding remainder, I'll write it down. When I'm finding remainder, I can write 6 in denominator as many times as I want. As many times as I want. So basically it is what? 7 by 6 into 7 by 6 into 7 by 6. How many times? I can write it 23 times. I can still write 1 by 6, 1 by 6 if I want to waste my time, but I will not write this. So when it is given 7 to the power 23 by 6, when single 7 is divided by 6, your remainder is 1. When another 7 is divided by 6, your remainder is 1. When another 7 is divided by 6, your remainder is 1. So basically when single 7 is divided by 6, your remainder is 1. And how many 7s were there? 23. So 1 to the power 23. It means that your remainder is still 1. Your remainder is still 1. Okay. I'll repeat once again. Let's take another example. Let's say the number is 18 square divided by 6. Not 18 square. 18 square is complete. Okay, 18 square divided by 7. 18 square divided by 7. The number will not be like this. You will find the numbers will be easy. 18 square divided by 7. 18 divided by 7. Let me take it as in this way. 18 square divided by 17. I want 2 as the remainder. So I'll take it as 16 here. Forget about it. Let's say this. Yeah. 18 square divided by 16. So when single 18 is divided by 16, your remainder is 2. How many 18s were there? 2 18. So 2 square divided by 16. 2 square divided by 16 is what? 4. So your remainder is what? 4. Now don't get emotional and divide this 4 by 16, 1, 1, 1, 4. Don't do that. Okay. The question is about divided by 16. So 16 should be there in your denominator. Though it's getting cancelled, yes, I agree. But 16 is there in denominator. So any number lesser than 16 can be a denominator. It could be 0, 1, 2, 3, 4, 5, 6, so on up to 15. Right? So 4 will be your answer. One more way or one more question which is very common is when 5 divided by 6, what's the remainder? When 5 divided by 6, what's the remainder? So, or else I'll take it as 5 to the power. Okay, let me take 5 only. When 5 divided by 6, your remainder is 5 itself. Your remainder is 5 itself, or your remainder is minus 1 by 6. All right. When it is 5, we can write it as minus 1. When it is 4, 5 by 6, we can write it as minus 1. When it is 4 divided by 6, we can write it as minus 2. Once again, if it is 17 divided by 18, we can write it as minus 1 as the remainder. Just try to understand. I'll try to make your life simpler. So if the question is given 5 to the power 24 divided by 6, 5 to the power 24 divided by 6. When single 5 is divided by 6, my remainder is minus 1. Now, how many 5s were there? 24. So minus 1 to the power 24 by 6. Minus 1 to the power 24 is what? Minus 1 to the power 24 is plus 1. So my answer is what? 1 itself. Did you understand? I hope it is clear. Had the question been given had the question been given. One more question if we'll see. Let's write here. 5 to the power 23 by 6. 5 to the power 23. When single 5 is divided by 6, my remainder is -1. Right? -1 to the power 23. -1 to the power 23 is -1. But you cannot represent your remainders in negative. So finally your answer will be what? 5 by 6, 5 itself. Okay. This is one way. Now, if it is not clear, there is one more way of looking at it. I don't like that method, but I'll share it with you. If it is 5 to the power 24, I'll take square of the number. 5 square is 25. So 12 into 2 is 24. 5 square by 6. 5 square is 25. When 25 is divided by 6, your remainder is 1. So finally 1 to the power 12, your remainder will be 1. Another one. Had it been given 5 to the power 23 by 6, I can write it as 5 to the power 22 into 5 to the power 1 by 6 by 6. 5 to the power 22 could be written as 5 square 11 by 6. I hope you are understanding. So 5 square is again 25 by 6, and 25 by 6 will give me 1 as the remainder. 1 to the power 11, it means that it is 1 only. But we need to remember this 5 in continuation. So into 5 by 6. So 1 by 6 into 5 by 6. 1 into 5. Finally, it is 5 by 6. So this is little lengthier. Right? Just look at it. I'll tell you the direct way. I'll show you how the questions are so that you will be able to solve it. Okay, let's move on. So look at this question. 67 to the power 67 plus 67 is divided by 68. What is the remainder? What do you think? Just give a try. Now, 67 to the power 67 plus 67 divided by 68. So I can write it as 67 to the power 67 by 68 plus 67 by 68. Now, 67 when divided by 68. Now, you know it is very near number, 67, 68. So if I'll do this way, 67 square and then 33 into 67 to the power 1 by 68, you literally have to find out square of 67, which is lengthy. You can use a square plus b square, or you can use calculator also and divide it. But when you are dividing a number in calculator, it will not give you decimal. It will give you in point decimals, right? Sorry, I wanted to say that when you're dividing 67 by 68, or even if you're dividing 67 square by 68, you will not get remainder. You will get answer as in decimals, right? But they are asking us to find out the remainder. So it has to be what? 67 will use that negative remainder concept thing. 67 divided by 68, it is -1. -1 to the power 67 divided by 68 plus 67 by 68. Now you know that -1 to the odd power is -1 only. So this will be what? -1 plus 67 by 68. -1 plus 67 is what? Plus 66. So your answer is what? 66. 66 is your answer. I'll say use this -1 method, negative remainder concept, rather than going into this square, because at times it might be a crazy calculation like here. And if you don't have calculator, if they are giving you calculator, then too, you can solve this without calculator quickly rather than using calculator. Because the moment you look at 67, 68, -1, super, -1 to the power 61, 7, -1. So -1 plus 67, my answer will be 66 directly. If you knew the concept, you can do the question pretty quickly. It will not take much time. Okay, fine. Let's move to one more. Okay, can you answer this question? What is the remainder when 17 to the power 200 is divided by 18? So the moment you looked at the question, and if you know that negative remainder concept, you will get the answer super quickly. I hope you would have got the answer. 17 by 18. Oh wow, it's -1. -1 to the power 200. It's +1. Answer is +1. Fine. So the questions will be like this only on remainder theorem. Don't worry that it would be typical questions. No, I've taken those examples just to explain to you. But if you understood this minus thing, better to understand it actually. Okay. All right. So let's just solve few more questions and then we'll move on. Hi, Jennifer. I hope you are understanding. Okay, so unit digit, the number is like 6324 to the power 1797 into 615 to the power 316 into 341 to the power 476. Okay. So like we discussed yesterday, any number ending with 5, whatever the power it is, doesn't matter. It will be always 5. Unit digit will always be 5. Any number ending with 5, whatever the power it is, unit digit is always 5. The same case goes with 1 also. 1 into 1, 1 into 1 is always 1. So you really don't have to be bothered about this 5. You don't have to be bothered about this 1. 5 into 1. Now, 4 to the, we just have to talk about this one. And if you remember, 4 power 1 was 4, 4 square was 16. 4 to the power 3 was 64. 4 to the power 4 was 256. So we just have to focus on these two parts. 4, 6, 4, 6, 4, 6. Can I say every time if it is odd? If it is odd, it will be always 4, 4, 6, 4, 6, 4, 6. Right? So 4 to any odd power, I repeat, 4 to any odd power is equal to what? Is 4 itself. 4 to any odd power is 4 itself. So you just have to take this 4. 4 into 5. 4 into 5 is 20, into 1 is 0. Or like 0 into, just focus on unit digit. So 4 into 5 is 20. That is, unit digit is 0. 0 into 1 is 0. So finally your answer is what? 0. Or instead of doing this, I could have done in one more simpler way. 615, 316, 341. This is a multiple of 5. This is even multiple. 5 into even number is always, 5 into even number always ends with 0. 5 into even number always ends with 0. Why I told you other method? Why I told you other method? In case if there is any other number, let's say if it is given instead of 5, if they had given you 6. So the number will be 6324 to the power 1797 into 616 to the power 316 into 341 to the power 476. So this one will be as it is. Also, we know that 6 to the power any number is also 6, and 4 to odd power is always 4. 4 into 6 is 24. So 4. Okay. So the answer is, for this question, the answer will be 4. For this question, the answer is 0. All right. I hope you understood, people. Fine. Let's finish off the one more last question on this one. Which of the following numbers will completely divide this? Which of the following out of this 12, 11, 25, 16 will completely divide this number? Let's discuss one. So those who have not attended any class yesterday, I'll suggest you to go to the previous video. And in last part of the session, we have discussed this unit digit concept. Okay, so you can understand from there. So which of the following numbers will completely divide 3 to the power 19 plus 3 to the power 20 plus 3 to the power 21 plus 3 to the power 22. So it is 3 to the power 19 plus 3 to the power 20 plus 3 to the power 21 plus 3 to the power 22. So if I take 3 to the power 19 common, this will be what? 1 plus 3 to the power 1 plus 3 square plus 3 cube. Because 19 I have taken 3 to the power 19 out, 1 will remain. I have taken 19, 2 will remain. I have taken 19, 3 will remain. Yeah. So now this is 3 to the power 19 and 1 plus 3 to the power 1 is 3, 3 square is 9 and 3 cube is 27. Right? So let's add this. 9 plus 1 is 10 and 27 plus 3 is 40. Sorry, 30. 30 plus 10 is 40. So you are getting 40 overall, isn't it? 1 plus 3, 4 plus 9 plus 4, 13. 13 plus 7, 13 plus 7, 27. Yes, it is 40. So this is equal to 3 to the power 19 into 40. Now, which of the following number will completely divide this? Do you think so that it will be divisible by 11? Do you think so it will be divisible by 11? Do we see any factor of 11? 3 to the power 19 will never be divisible by 11. 40, so this option eliminated, right? Just divide by 16. So if you write, okay, let me write it this way. 3 to the power 19 into 40 by 11. Do you see any number getting cancelled? 3 to the power 19 is like 3 into 3 into 3 into so on 19 times into 40 by 11. So do you see any factor of 11? No, option eliminate. If I write 25 instead of 11, if I write 25, I can write further as 5 into 5, right? So if I write this 40 also as 5 into 8, 1 5 will get cancelled. 1 5 will get cancelled. But what about this one more 5? We don't have this one more 5, right? To cancel it. So even 25 is not possible. right? Now, if I divide it by 16, 3 into 3 into how many times? 19 times into 40. 40 can be written as 5 into 8. If I divide by 16, 8 ones are 8, 8 twos are. But do I have any factors of 2? I don't have. So this is also not possible. So 12 is the answer. Now you see how it is happening. 3 into 3 into 3. How many times? 19 times. Into 5 into 8. And 12 can be written as 3 into 4. So 3 will get cancelled out of this 19 times. 1, 3 will get cancelled. And 4, 1, 4, 2, 8. So your answer is what? 12. Okay. Is that clear? I hope so. So a direct way of solving this could be in this way. 3 to the power 19 into 40. It means that it has to be a multiple of 3. It has to be a multiple of 4 also. So if I see 11, no, it's neither a multiple of 3 nor a 4. 25, no. 16, no. So one thing is that if it is 44, like if I'm getting 44, I can say, yeah, 44 divides 11 completely. But here it is 40. So you can just check 40 is not divisible by 11. 40 is not divisible by 25. 40 is not divisible by 16. But 12 can be written as 3 into 4. 12 can be written as 3 into 4. And we have plenty of 3's with us. So 1, 3 will get cancelled directly. So yeah, 12 will be the answer. Okay, fine people. So I hope you understood, right? So tomorrow we will do factors in short, because that I don't think so that it's very important one with respect to IND SAT exam, but like I said earlier, it could be. So these are 2-3 things and when I told you LCM question again. So tomorrow again we will be solving more and more questions on number system. So how we will go, that's the plan. We will solve the concepts, and next day we will be like when we are doing concepts we will be solving questions also, but next day we will be solving more questions, and next day we will try to solve questions first orally or like mentally without touching pen and paper. That would be our first approach, but there could be certain questions where you need pen and paper, so we will go with pen and paper also. But our first approach would be to try mentally. If we have to challenge ourselves, we will be challenging ourselves little, so that we would be preparing for the worst, like I said earlier. Okay, fine people. So have a good day for the rest of the day. Enjoy well, sleep well, eat well, and I'll also say, please start putting all this into action. Like whatever we are doing, start solving it by your own also. You can refer some of the websites. Tomorrow I'll let you know the website's name. But if you are going through these videos also once again and trying to solving the question by your own would be great. And if you know some of the websites, or if you can just Google about aptitude questions, you will find a number of questions, right? So go through all those questions and try to solve it. Make sure that you are consistent in your action, because if you will be consistent, you will be able to see the results. It should not be the case like before 10 days of the exam you are sitting it up. But anyway, we have planned it nicely. We will be keep on doing the revisions for whatever the topics we are doing. So be regular, and like I said, tomorrow will be the numbers revision. So we will be solving more questions on number system. All right, fine people. So I'm signing off. Thank you so much. Take care. Enjoy. Bye bye. All the very best.